Welcome to Ask and Learn.
With what we have given. So we have given that this connection is made and this connection is broken in the beginning. So this C1 charges with the 24 volt. So we can find the charge stored on capacitor 1. That will be this one. So let's denote it as Q0 because that won't be the final charge on C1. So let's do the multiplication. We know that C1 is 1 microfarad and V0 is 24. So the answer is 24 microcoulomb, not microfarad. I'm sorry about that there. Then let's find out the net capacitance of C2 and C3. So they are in series, as you can see here. So net capacitance C23 here is equal to C23 inverse is equal to C2 inverse plus C3 inverse. So C2 is 2 microfarad, C3 is 2.4 microfarad. If you perform this calculation, you get C23 inverse as 0.916. So taking inverse again, you will get C23 as 1.091 microfarad. Now, what we do after this is that we break this connection completely, and then we have this connection made. So we have C23 here in parallel connection with C1. So as you can see, they are in parallel connection, so they must have same potential difference. So let's say this is point C, this is point D. Potential difference between point C and D is same for both C1 and C23. Remember that this is C23, not C2 and C3 individually. So let's start with this Q0, because once you make this connection here, C1 deposits some charge on this series combination and C charge is depleted on C1. So Q0 is distributed among C1 and C23 this way. So Q0 is Q1 plus Q23, and Q0 we have calculated it in the beginning here, and we also know Q1 is equal to C1 V1. Also Q23 is C23 V1, because as we said in the beginning, they are in parallel connection, so they have same potential difference. So from this, you can simplify for V1, and substituting all the values, you get 11.48 volt. So that's the value of V1. Now, next we are supposed to find the charge, all the charge. So we are supposed to find charge. Let's find Q1 then. Q1 is equal to C1 V1. So we know C1 is still 1 microfarad. So and V1 is 11.48. So this gives you simple value 11.48 microcoulomb. So that's your Q1. And then let's find Q23. And remember that C2 and C3 are in parallel. So they have same charge. So whatever charge is here, negative charge goes here. Again, the positive, same amount of charge here, again, negative charge here. So if you find Q23 is equal to C23 V1, which is equal to, as we know, C23 is 1.091. So that will be multiplication of 1.091 with 11.48. So that gives you 12.52 volt. Oh, sorry, microcoulomb. So that's the charge on Q23 on the system of C2 and C3, since, as we said before, they have same charges on each plate, except they're alternating positive and negative. So Q23 is equal to Q2 is equal to Q3 is equal to 12.52 microcoulomb. So we are done with finding charges. Now let's find the V2 and V3. So we know now Q2 and Q3, right? So Q2 is equal to C2 times V2. We can find V2 from this. So V2 is equal to Q2, which is 12.52 microcoulomb divided by C2, which is 2 microfarad. So micro cancels and you get answer in terms of volt. So the answer here is 6.26. Sorry about that. So that's your value of V2. Then we are supposed to find V3 the same way, which is Q3 divided by C3. So Q3 is also the same as 12.51. So except C3 is 2.4. So your answer here is 5.218 volt. So let's summarize now. Let's see what's a V1. V1 is equal to 11.48, as you can see here. That means it's 11. We are keeping only two significant digits. Q1 corresponding is equal to 11.48 microcoulomb, which is again 11 microcoulomb. Then V2 is equal to 6.26. So let's keep it as 6.3 volt. So Q2 is equal to 12.5. So we can approximate it by saying it's 13 microcoulomb. Similarly, Q3 is 13 microcoulomb, and V3, as we found before, 5.2 volt. Thank you.